So the next question what we are going to study is called as your decoder. Okay, decoder, which is asked usually for 6 marks or 8 marks. Okay, so you know that decoder is opposite to that of your encoder. So before going on to the topic, let me tell you, or let me just show the difference between the 4 important circuits which may be confusing. One is your mux, second one is your demux. Okay, block diagram, then you have encoder and you have decoder. Okay, so what is meant by a multiplexer which converts 2 power n inputs into a single output, right? One output. Opposite to that of your mux is your demux. So one input and 2 power n output. Okay, now what is meant by an encoder? Here just little bit more or less equivalent to that of your multiplexer, where you have 2 power n inputs, but it is converting from one code to the another code. So it has few outputs, so n output. Okay, so opposite to that of your encoder is a decoder. So you will be having n input and 2 power n output. Okay, so instead of single, here you have few outputs, and here you have single input, you have few inputs. So this is your difference between your mux, demux, encoder and decoder. So a multiplexer is a circuit which converts your 2 power n inputs to a single output, whereas your encoder is coding from one form to the another form. Okay, so for example 8:3. So now let's see the decoder circuit. Okay, so the block diagram of decoder will be the same. Now you will be having n inputs and which will be converted into your 2 power n outputs. Okay, in addition you will be having your enable pin, active high enable pin. Okay, so what is meant by a decoder? How can you define a decoder? A decoder is a combinational circuit that converts binary information, information from n input lines to a maximum of 2 power n output lines, right? So this will be your definition of your decoder. So I can write that n to m line decoder. One of the best example is your 3 to 8 line decoder, which is usually commonly asked the question. Okay, so first we will draw the truth table of your decoder. So what will be your inputs and outputs? So you will have 3 inputs. Let me take it as x, y and z, and your output as d0, d1, d2, d3, d4, d5, d6 and d7. So what will be your combination? 3 inputs, right? So 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So it will be converting it into, during your input as 0 0 0, you will be having only D0 will be enabled. 0 0 1, you will be having your D1 to be enabled. 0 1 0, you will be having D2 will be 1. Similarly 0 1 1, you will be having D3 to be 1. 1 0 0, you will be having D4 to be 1, and 1 0 1 you will be having D5 to be 1, 1 1 0 you will be having D6 to be 1, and 1 1 1 you will be having D7 to be 1. So what will be your expression, Boolean expression? You will be having 7 different Boolean expression, right? So I am going to write it in the, let me write it here itself. So what will be your D0? D0 is equal to 1 only for the case x, y, z bar, right? X bar, y bar, z bar. So what will be your D1? D1 will be, it is 1 for the case 0, 0, 1. So X bar, Y bar, Z. What will be your D2? D2 is 1 for 0, 1, 0, which is equal to X bar, Y, Z bar. D3 is equal to 1 for 0, 1, 1. So X bar, Y, Z. D4 is equal to 1 for the case X, Y bar, Z bar, right? X, Y bar, Z bar. D5 is equal to 1 for 1, 0, 1. So X, Y bar, Z. D6 is equal to 1 for X, Y, Z bar. And D7 is equal to 1 for high values of X, Y and Z. Okay, so this will be your logic expression, and the next is your logic diagram. So what will be your logic diagram? So your logic diagram will be, let me draw the logic diagram. So what are your inputs? You have X, Y, Z. So this will be X, Y line and Z line. Now you should have a X bar also, right? So for that you will be taking a NOT gate. Here also Y bar, you will be having a NOT gate, and similarly Z bar, you will be taking a NOT gate. So in the output you have, what are the outputs you have? 0 to 7, right? So 8 AND gate. 1, 2, 3, 4, 5, 6, 7, 8. So you can take it as Y naught. I am taking it as D naught, D1, D2, D3, D4, D5, D6 and D7. So if I write it, it will be easy. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, sorry, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So 0, 0, 0. So you have Z bar, right? Y bar and X bar. Next is 0, 0, 1. Same X bar, Y bar, 1. So it is Z. Next you have 0, 1, 0. So X bar, Y. So you have Y and 0, Z bar. X3 is equal to 0, 1, 1. So your expression will be X bar, Y, Z. So X bar, Y, Z. 1, 0, 0. So it is X, Y bar, Z bar. X, Y bar, Z bar. Right. Now if I can extend this. Next you have 1, 0, 1. So X, 0, that is Y bar, X, Y, Z. So this will be your Z. 1, 1, 0. X, Y, Z bar. Okay. Last one is 1, 1, 1. X, Y and Z. So this will be your logic diagram of your decoder. Usually it will be asked for 6 marks or 8 marks. So you can, when you write this, you can replace it by X bar, Y bar, Z bar. Here it will be X bar, Y bar, Z, X bar, Y, Z bar. Similarly here X, Y bar, Z bar, X, Y bar, Z, X, Y, Z bar, X, Y, Z. Okay. If you, in the truth table, if you want, you can add one more pin, that is your enable pin. When your enable pin is 0, no matter what is your input, all the output will be equal to 0. So for all the other cases, enable, when enable is high, you will be having the corresponding output. So this is the block diagram. Then your truth table, logic expression and logic diagram, which you will have to write for your 6 marks or 8 mark question.